All right. Hello, how we doing? Everyone good? Now, I will start off by admitting that I'm completely aware that I stand between you and the hair of the dog, okay? Getting out there and starting and finishing the party from last night for the rest of today. So this is the last session for the event, so I'll end on time, so I'll start a little early to make sure that happens. So I'll be covering software as a service architecture, so if you're not interested in software as a service, it's probably your time to hop up and get that nap you've been waiting for all week. But if you are, please stay. My name is Matt Tavis. I'm a Principal Solutions Architect at Amazon Web Services. I've had the pleasure to be at Amazon for 9 years now, so that means I've gotten a chance to see all this grow. And it's really exciting to see how our customers, you, have really evolved your delivery of software and solutions on top of the platform. And this is what I think is kind of the next generation in how people will be delivering intellectual property and IP through software delivery mechanisms. So it's really about SaaS in my mind. So just as a show of hands, who's building or delivering a SaaS solution today? Oh, good. All right, so then we can just all go home. Nice. You guys all know about this. I don't have to tell you anything. It's fantastic. Well, all right. For those of you that want to maybe pick up a few tips, please stay. The idea here is these are some lessons we've learned from our customers, people we've talked to about their approaches, and hopefully there'll be a few things that you hadn't thought of before. And if they're just reinforcing your design, that's great. Fantastic. So first off, why SaaS? I won't spend a lot of time here because you guys obviously understand why this is important. But I think there's several key factors that change in terms of how you build and deliver software and why SaaS makes a lot of sense for both your customers and yourself. What it really enables, number one, reaching new markets, right? The ability to have a customer online, try out your products without having anyone have to go out there and install product or build out hardware, set up an environment. That's huge. It gives a much shorter sales cycle. It enables your sales team to move faster. It enables you to, with almost no sales team, get into accounts that maybe weren't available to you today. It also gives you the opportunity to reach a different tier of customer potentially, where maybe you were a really expensive licensing product, now you want to offer maybe a lower tier offering for a lower price, don't have the sales support. A SaaS offering can give you that capability, right? Growing the existing installed base. So you may be in a customer today, but your licensing is based on the number of seats. The internal IT team is worried about who gets to use the software, so you're limited in terms of who inside that organization can use that product. So the ability to have SaaS be more driven by usage and consumption, which is driven by actual business need, allows internal IT teams to open up those doors a little bit further. They know that the consumption of your product will be related directly to business need, and therefore they don't necessarily have to cap who gets that product installed or who has access to that service. So you can have a broader potential install base in existing accounts. Disrupting existing industries, right? Areas where there might be an entrenched player, but you've got a great idea about how you can evolve that space. SaaS gives you a lightweight, fast delivery model that allows you to get into customers that maybe weren't even thinking about you relative to the entrenched large offering market. And the last is really probably the most important, I think, to me and to customers and even to you, is the ability to accelerate new product feature adoption and release. Right? There's no ship cycle related to I've got to build the feature, get it through testing, press the CD, get the customer to agree to buy the next version, wait for them to purchase new hardware to install it, and then deploy it in the environment. Now the delivery of new features is near instantaneous. You can roll those out quickly, and you can make them available to your customers right away, which also means you can evolve your product very quickly. And we'll talk about that more. So whether you agree with all those points in the previous slide or the IDC summary is independent, but I think the key message here is software delivery is evolving. The idea of on-prem still exists. It's probably going to exist for a while, but people are moving on to hosted models, the old ASP model, obviously very popular still. We see two models beyond that, adopting to an AWS platform where you're then leveraging those higher level services beyond just the application itself, and then moving to SaaS. And I think what I'm trying to get you guys to think about is how do you get to 4 as fast as possible, right? But 4 is the target. I'm sure there'll be a 5, a 6, and a 7, but we'll probably talk about that next year. So when you think about this, if you have an existing product base, you got to think about how do I get there? What do I want to do? And there's many paths. And we've seen there's 3 examples from our customers out there today that are worth talking about. The first is the extend model, right? I have an existing desktop or installed product. I want to provide SaaS-like features. I want to provide a new feature set, but I don't want to build it into the existing install base. I want to have this as an extension. So you look at example, Autodesk Fusion 360. Now you can have an installed desktop product that has the capability to then do, say, simulations, translations, backup and storage as extensions of that product, giving you a foothold into a SaaS offering and then building upon that over time, right? That's one common model. The next is the idea of leverage and rebuild, right? Infor announced with us very recently that they're planning on going all in on AWS, taking their existing entire product suite and leveraging that as a SaaS model on top of AWS. There are millions and millions of person hours of development effort built into that product base. They're not throwing that away, obviously. They're going to take those components, rebuild them around a SaaS model, leverage that existing footprint, but then have a whole new delivery mechanism behind that. That's another potential approach. And then, of course, there's customers partners like Sumo Logic, where their idea was ground up. Let's just rebuild the entire thing, designed solely around a SaaS approach, cloud-first, SaaS-based model. And obviously, they can drive out probably the most efficient architectural designs by taking that approach. But for them, they decided any existing IP wasn't necessarily critical for them in terms of delivering that. So you have to think about what your footprint is today and what you're going to want to bring forward into this new model. So let's talk about the differences in the software evolution that I talked about before. So number 3 is I skipped 1 and 2 because I'm not really interested in those and we don't want to promote them. So it's really about what's the next one, which is AWS obviously is the first step on before 4, and that's the idea of I have an application stack. It's very consistent with what I had in my application hosting model of an interaction layer, application layer, object storage, data storage. But I now have access to the analytics platform. I now have the ability to do tightly coupled integration with IAM for policy management, fine-grained access control, and I have more advanced features like monitoring for the entire environment that maybe I didn't have in my traditional ASP hosting space. So it's the ability to capture some of that higher level capability, higher level analytics and analysis tool set that comes with moving into the AWS platform. But what I'm really trying to get to is this. And I'm sure it's totally obvious from the slide, so I won't even describe it. All right, I'll take a few minutes. So the idea is here, now you have the traditional delivery model for an application. You have a delivery layer, DNS, edge caching. You have an interaction layer, which could be anything from workspaces for a desktop client to an EC2 instance running web servers, to AppStream for streaming components. Authentication and authorization, oftentimes this is tightly coupled with applications, so in many cases they're wired together, although this could be imagined as more of a platform component as well. But the ability to manage things like rights, accounts, users, you'll notice that it starts to evolve when you think about this model. It starts to evolve beyond just a single installation. So now you're thinking about not just users in a single company, but many, many companies. So your multiplicative factor of 10,000 companies using your product with 10,000 users is, I'm going to go with 1 million. I think that math is right. I'm not sure. You can check me. And then the application layer, where you're obviously doing the application components. And a lot of this stuff is all part of your existing product, right? The one thing that might change here to think about is the data access layer. So in the data access layer, now you're storing not just data for one particular customer, but potentially many customers. So you have to think about how am I going to do security and isolation of individual customer data? How am I going to allow my data to move over time? And I'll talk more about that. I think it's an important concept of the lifecycle of data here to talk through. But the idea of having multiple data sources and data stores that you can then move through. So as you may shard or partition or grow your data storage platform, being able to move customers around or data around appropriately within the architecture to optimize for performance or particular customer workloads and needs. And that's the program side. The next side is the platform side. And I'll talk more about the split here, but with the program comes the idea of a platform. So in a SaaS, you're not just delivering the software itself, but you're also doing things like ordering. How do I purchase this product? Provisioning. What happens when my customer signs up? What infrastructure do I put in place for them? Metering. If I'm going to charge them per usage, how am I capturing that information so that I can, at the end of the month, deliver a per usage bill? Billing, obviously, that's the next piece. You want to make money on this, I'm guessing. Monitoring, how do I capture the real-time information about what's happening in the environment, not just maybe one program, but many of them, and even the components in the platform themselves. And then, of course, analytics. And we'll talk about analytics more. I think this is a critical piece of any SaaS architecture because it allows you to measure and analyze what's happening in the environment and evolve over time. So let's talk about some best practices. So as you saw in that diagram, I think it's important to think about the idea of separating the platform from the program. First reason, of course, is that if you have a platform, you can deliver multiple services. The idea that you're going to have one SaaS offering and it's going to stay the same forever and never evolve, probably unlikely, unless, of course, you have a short-term business model that has you exiting somewhere. You're going to evolve over time. Things are going to change. You're going to want a platform that you can reuse. It also allows you to do things like I want a V1 and a V2 and a V3 and a V4 that may sit side by side over time. But the ability to have a common measurement platform, a common ordering platform, and provisioning platform really gives you the reusability across the multiple versions of your offering. And of course, a lot of this is about designing for shared services. You guys have probably seen a lot about service-oriented architecture. I'm not going to talk about that, but that's a key component here, a key thought process. The idea of microservices also comes into play in this type of a model. But really designing around that and having your mental model being day one, how do I componentize this architecture, and how do I then separate the platform components from my core program? And then, of course, future-proofing through abstraction. So I talked about this idea of data movement. It's a really good example of future-proofing. The idea that there's no shared data sources, but rather data services, the idea that you have then maybe even tiered data storage over time, are going to be important concepts when you get to how am I going to grow this data footprint for my application, right? So if you're successful, which is the goal, you might start with 10 users, and that's great. And then 7 years from now, you have 10,000 users, right? How has that data changed over that time? How are you then going to protect your program from the movement of data? So for example, customer X comes in, it's your first big account. They have 10 times the transactional volume of anyone else. They're going to put an unbelievable load in your data tier, right? You're probably going to want to put them in a separate set of infrastructure, a separate set of data services, or maybe protect the other customers from the impact of that one single customer. Having an abstraction layer around data storage and the ability to maybe look up where that data belongs for a single customer is an important layer within the architecture, so it allows you movement and flexibility over time. And if you think about design for a SaaS offering, we talk about scale in AWS in general for any application, but SaaS complicates things. It's an extra multiplier on top, right? So if your app is successful and grows, that's great. That's one customer. If all 10,000 of them are successful and grow, that's a 10,000 times impact, right? So you really have to think through scale impacts and how you're going to deal with the migration and replication and movement of services through the architecture. So abstraction's a key piece there. Another idea is to design for multi-tenancy. I just made that up. Well, not just now, but because I did the slide before now. But anyway, so the idea is now you have many accounts which have many users and they have many roles, right? So this multiplier quickly grows in terms of the number of individual user pieces of information you have to store and understand. That goes and that hits your entire architecture, right? That hits how am I going to store that data to protect customer X from customer Y access. It hits it in terms of if I have 2 accounts and one is a free tier and one is a premium tier, how am I going to deliver the performance guarantees for 2 different offerings? So my SaaS offering might have one for the free tier, it's a best effort translation capability, and then for the premium customer who comes in later, I'll do it instantaneously, right? That's potentially 2 sets of infrastructure. One is a queue that drops it into maybe some spot instances that are processing that as available for a low cost, and then the other is a live EC2 instance pool that's doing it right now immediately for that customer for quick response times. So you got to think about how you're going to split that service offering and even the multiple capabilities in that architecture for a multi-tenant type environment. So securing it and then delivering on your SLAs for different types. And then, of course, knowing the lifecycle of your data. And I'm going to cover this more in just a second, but the idea that the value of data and its impact to your customer changes over time. Whether people need to see it, whether you're going to continue processing it, whether you actually are ever going to serve it up again. These are all things that will change with time. So thinking about the different storage options. And let me walk through an example for that one. So obviously this isn't somebody's explicit architecture, but it's an idea. In the first few minutes, you're getting data in multiple different sources. You've got Kinesis streams, you've got stuff coming in from the web with your web logs, you've got EC2 instances collecting information. These things are all happening all the time within minutes. You've got, obviously, RDS instances, storing data, capturing transactions, and you might be uploading files to things like S3 buckets, right? This is all happening in that first stage, right away. This is the live data that's coming in. This is the stuff you're maybe immediately delivering back out. Over time, within maybe minutes, maybe lots of minutes, hours, you might say, well, now I want to start processing and analyzing. What's going on there? What's in my analyze phase? I now look at the transactional information happening in my RDS instance, and I'm processing all my web logs because I want to make some recommendations to my customer. Right now, I want to process this information and then generate another data set, which is important for real-time recommendations or promoting certain features or products within my offering. Right? Now I'm taking that, I'm pumping that into something like EMR. I'm then pumping the result into a DynamoDB table for delivery out to the customer. Right? Now that data, this data is still highly valuable, but now it's gone from raw to some basic process level. The next is to say, I want to maybe summarize that. I want a dashboard. My executives are asking me what's happening in the environment, what's the current run rate for the business, how are we evolving, how are our customers evolving in consumption usage. So now I'm doing a summarization. I'm going to take what's happening, maybe even again in EMR, and pumping the result of that into Redshift as a storage model. So now I'm building a data warehouse around what's happening in my environment. And it could be faster than days, but obviously this is an example. And then over the weeks, I might then go from summarizing to aggregating. Now I'm going to look at storing the entire history of all of my transactions and information. Well, I don't want necessarily every last order stored forever in my data warehouse. I might have that information stored on S3 somewhere. But I want a data warehouse behind it. I might do some more aggregation. And then there's a tiered storage model that comes into play. The orders and the information people placed maybe in the last 6 months, super critical. People look at it all the time. They're really interested. This is what's happening. Stuff that's older than, say, 6 months, you might not even put that in the database at all. You could imagine extracting that information from things like RDS and DynamoDB, putting them into an S3 bucket, so when customers ask for it, you can still deliver it and pull it up with maybe a slightly lower response time, but because it's less needed, the customer experience actually isn't suffering. It's page 15 of the search results, right? It's coming up. You're pulling it up, but you're delivering out of a different storage model. Significant cost reduction in terms of overall storage, and it also makes your cost of your existing RDS and Dynamo instances significantly cheaper as well. And then, of course, there's archive, right? Eventually, you're going to want to move this in through lifecycle processes into Glacier. You're going to want it forever, but if you're not looking at it after a few years, just put it someplace where it's safe. This is a critical one for us, the idea that you should collect everything and learn from it. So obviously, you want to closely monitor the infrastructure. You want to scale on it. That's a pretty straightforward, obvious thing to do in a highly scaled environment. You want to collect your metrics and store them reliably and durably, right? As information is coming in, you can pump that data directly to a source like an S3, and then eventually you might process it with an EMR or some other processing technology. But fundamentally, capturing this information is critical and holding on to it. You may not know what to do with it yet. Don't get me wrong, I'm not expecting you to analyze it perfectly the first time around, but you'll want to know. Because over time, you're going to want to actually know who did what in the environment, and you'll want to know who your customers are and what they're doing. So this is an important concept I think people don't always capture in their first architecture design. The idea that identity, who's actually performing what functions in the architecture, should flow all the way through. Right? What that means is when a customer comes in and they access your application, you can understand who that customer is, in fact, all the way down to the individual user, what functions they're performing within the architecture, what data they're accessing, and what components of your architecture they're consuming. We have, as an example, we had a customer who had built out a great SaaS offering, but had not done that component with search. Right? They had failed to instrument the search service with information about who was doing what in the search service. The cost of search started to skyrocket relative to the cost of the rest of the infrastructure. They had no ability to go back and say, oh, I know how I can find out who's doing this and then understand what the use case is that's driving this overall cost. They hadn't collected the customer information all the way through. And I'm not talking about PII, I'm talking about obfuscated customer IDs, the ability to store information to relate back to what activities are being performed. It's a key piece in the architecture because the most important thing is you can learn from this and you can profit through analytics, right? The goal of a SaaS obviously is to get customers, but when you think about one of the capabilities of SaaS in terms of evolving your architecture, that is where this measurement and analysis comes into play, right? Without the ability to measure and analyze what you've done, you can't make a credible evolution of your architecture and product, right? You can change your product all you want, but without data and metrics, you don't know if you're doing the right thing, right? So this is where it's important. And that actually gives you the ability to monetize. And I'll pause there and drink. So it gives you the ability to monetize on the environment. Now, you can look at what customers are doing, and you can even change your product, come up with different SKUs, different offerings. You can see there's a handful of customers that are driving around this particular product set. Hey, you know what? I can turn that into a new gold offering that's a different SKU of my base SaaS offering, and I can charge a different cost for that. But you can't do that without this metrics, right? So, of course, there's some components that sit behind this. An example, in terms of these core services might be something like metering. And obviously, there's a whole bunch of services tied into this. You have things like Kinesis and S3 and DynamoDB and RDS. Things are happening all the time in those environments. You want to capture what's happening. And of course, I've taken the liberty to create an icon for the new Lambda service because I didn't have one. And luckily, Lambda is a letter in the Greek alphabet, so it's pretty easy to find that. And slap that on the side of an EC2 cluster there. But the idea here is that capturing event-driven activities, what's happening in the environment, capturing that real time, and then responding to it. Storing that, passing that on using, and in this case I'm using SQS, but this could be Kinesis as well. The idea of capturing information, what's happening, who's the user, what's the usage type, what are the units, what's the period of storage or period of consumption. Passing that both from the application instances themselves as well as from the data storage services. That allows you to aggregate that information, store it reliably in something like a DynamoDB as a big table, gives you captured information about who's using what, which you can obviously query at any time, and then pump that data onto the next layer. So here's what's happening after you've metered. Well, I'm capturing that. I've got a metering data service that aggregates the view, so I can then put that into billing. So I can send information off to my customer about you owe me X, Y, and Z this month. Or analytics, who's using what at what times. Analytics is another great example of this type of architectural approach. Application instances, you've got app data, metering data, billing data, all sitting there, and you'll notice those are all read replicas. An important concept in any kind of analytics or processing architecture is do not read from the master. Thank you. You'll make me very happy if you don't ever do that again. But the idea of replicating and creating replicas of your core data stores that you can then process from and read at any time to pull into more of an analytics architecture. Again, things like log rotation on your application nodes, pumping that data to S3, database exports with data pipelines. Again, Lambda could be consumed in this model as well. It depends on what the right model is from an analytics and responsiveness perspective. Those buckets and that data being stored in S3 could then run through a cluster to generate your data warehouse view of what's happening in the environment. And that could be, we talked about it being days in the earlier data lifecycle example, but this could be minutes as well. Whatever makes the right sense for your architecture. Pumping that information along into a Redshift data warehouse, which allows you to then build things on top. So that cluster can also be used to generate customer-facing recommendations, as I mentioned, generating static reports. And then, of course, you can build a complete reporting portal over the top where people can view the current state of the environment through those well-known reports, as well as even a direct access query, using a BI client like a Tableau or MicroStrategy or whatever makes sense for access into that Redshift cluster. All right. So often this is the next question which comes up, which is, okay, these are great ideas, but my software is not quite there yet, right? I've built something and it's not really designed around that lovely, level 4 model, if we want to call it that. How do I get there, right? What are the approaches I can take? And there's 3 major approaches that are being viewed from a SaaS perspective and what we're hearing from our customers. The first is isolated customer stacks. And we'll talk about this in a second. It's pretty obvious. I think you'll all get it. We can probably zip past it really fast. The second is more of a pure SaaS architecture, which is really what I'm trying to promote we're trying to promote with this number 4 target, is the idea that you design around SaaS to begin with. And the third is a sort of a mid approach around containerization. So when you think about isolated customer stacks, now you build out your load balancer for customer X, your EC2 web servers, app servers, and your database for that customer, right? Customer 1 now has a complete stack architecture. This is actually very similar to the application hosting ASP model. I'm going to install all my software on a stack for a distinct customer. The nice thing is they have dedicated infrastructure. They can have a completely different configuration from everyone else. It also is really easy to get started this way if you have existing software. Installing it in this architecture gives you that quick hit ability to deliver an endpoint or a service to your customers. The downside becomes, as you think about provisioning, you're going to provision more and more of these stacks for your customers over time, right? You're going to end up with effectively urban sprawl, is the way to think about it, or infrastructure sprawl. Lots of resources all over the place, tagged appropriately, so that's good, you know who they belong to. But ultimately, your efficiency from a utilization of resources probably isn't going to be as high as you want it to be, right? And that'll hit your bottom line over time, right? So it's good as a great place to start. Many customers start there because it gives them a quick hit win to offer a service capability. You'll notice from a provisioning perspective and tagging perspective, from the way you think about billing in this architecture is, well, I tag my resources, I turn them into cost allocation tags, I then pump them through the detailed billing report, and then I analyze which customers are using what capability or what infrastructure resources, and that's how I might generate my bill. So it saves you maybe some time if you think about the cost of analysis of resources and maybe simplifies some of your metering because you're just going to charge them in the whole stack initially, right? So it is a pretty simplistic approach, but it certainly is a great way to get started. The next one is the pure shared model. So in this case, customer 1 and 2, they come into a common entry point. Maybe you have vanity subdomains, things like that, or even vanity domains in general. But they're all coming into a common set of load balancing infrastructure. The web tier and app tier are completely shared pools. Now, this has big architectural impacts, which means every request coming in, you have to identify who the customer is, what they're doing, and then when those requests are processed in the web and the app tier, any rules associated with individual customer configurations have to be figured out dynamically in those things. So the code across all of your configuration for your customers and how you then process requests has to be consistently deployed across the entire infrastructure. But it does give you a very consistent model, right? It means you then can use simple things like auto-scaling, like how I'm going to deal with provisioning. Well, provisioning is simply the fact that as traffic grows, my infrastructure grows. And because all customers and all processing rules are consistently deployed, they can hit any instance in the environment. It gives you great, obviously, high availability characteristics, but it comes with maybe some software architecture changes. How do you think about metering in this environment? Right now, I have to then calculate either from my web logs or through generating outputs from my requests. I have to pump information into my metering service to calculate who's using what resources and what costs might be associated with that. So there is some instrumentation components, and it does require more of that complete platform stack be in play. And of course, the whole thing runs on one MySQL instance, right? Sure. It might be more than one. I just thought I'd check to see if you were awake. And then containerization. So containerization is this new model. I think a lot of folks are obviously well aware of Docker and LXC and BSG jails and all that kind of fun stuff. And containerization is taking advantage of this new approach. I think the big win from a software architecture perspective is it allows your products that may pre-exist to sit side by side inside of a single EC2 instance without any conflicts around maybe network resources or libraries, things like that might need to be deployed. You can also deploy multiple components in a single box. You can really sub-slice, if you will, the EC2 infrastructure specific to your resource needs at that time for that container. Also fairly fast in terms of deploying them. What you'll notice here is that this is one big auto-scaling group, or cluster in this case, because from a containerization, when you think about how I'm going to do provisioning, well, of course, you're going to sign up for the preview of the brand new EC2 container service, and you're going to use that. All right? This slide looked really different when I delivered a version of this on Tuesday, where you were doing all the container work yourself. Turns out now it's a lot easier. Well, that's good. Big win there for everyone. So in this model, You could be using, obviously, an RDS instance. RDS Aurora, for example, would be a great data storage model behind this. But you could even imagine containers of MySQL, small MySQL databases being deployed as well. So this container model allows you to define tasks. And so provisioning is to deploy a task, which is the entire stack for an individual customer. So it still gives you that kind of stack-level isolation that you like from the isolated stacks, but it gives you much better resource utilization. And you're deploying to an existing pool, an existing cluster of instances, so deployment time is very, very fast for something like that. And so that's how, and then metering would be really to measure from the container service information about what containers are running, how long they've been running, and capturing that information as a way to collect what they're doing, and whether they what you need to charge them at the end of the month from that. This is always a popular one. I think we just say this all the time. It's kind of a popular thing to say, is optimizing for cost and performance. The important thing about SaaS, though, I think it adds an interesting twist, is that cost and performance are not necessarily at odds. So you can have a low-cost offering for a free tier or a freemium tier, and then you can have a high-performance offering for a high-end enterprise customer. And both of those can sit side by side inside your architecture. So the concept of distributing requests into unique queues based on priority, right? So my freemium tier customers, they come in and they end up in a SQS queue for deploying work. That gets dropped into a host of spot instances, right? Lower cost. I've driven my overall cost model down for my freemium tier. And it will get delivered, but the response time will maybe be a little bit slower. For my high-end customers, they're going right into a live queue that's pumping right into a live pool of EC2 instances that are doing this analysis immediately, and potentially in some cases even push into a full synchronous response model, right, if that's appropriate for that customer base. That's going to be more expensive, obviously running that pool all the time, maintaining it, but it turns out that's also going to map back directly to what your customers are paying you for that enterprise-grade offering, relative to the freemium tier. So this idea of optimizing how you then leverage and deploy resources relative to your business model is actually important. You want to think through those components. The idea of horizontal scalability, parallelization, none of this changes, obviously. Anywhere we can maybe consume bits of Lambda for some event processing models would make a lot of sense in this type of approach. And the ability to leverage scalable services. So the idea of instead of running a whole bunch of infrastructure for certain pieces, say queues or installing and running your own database, rather leveraging things like DynamoDB or SQS or Redshift where it makes sense, because you can drive down the overall cost model by using a scaled service that will grow with you over time without any additional work on your end, any additional cost to carry that infrastructure when it's not necessarily being consumed. And then, of course, everyone likes to secure and isolate everything. I think it's an important one. Many of these are common security requests, common security models that everyone's going to do in any application architecture. I think SaaS, the twist that SaaS adds is how do you think about the protection of data for your customers? Because customers ask us all the time about security. And so if you're delivering a SaaS offering on top of us, they're going to ask you about security, right? So how are you going to protect that data, isolate it, provide a data model that allows for isolation of access to the data appropriate to each individual customer, keeping that separate. And that's where we're really hooking into a lot of the core services like IAM for fine-grained access control. The new key management service would allow you to do individual keys for individual customers if that's appropriate. Doing network isolation where appropriate, if you do have to do isolated resources for a customer, giving them a view into how you're using VPC, network ACLs, and security groups to isolate components. Integrating where appropriate directory service or Active Directory from existing infrastructure as an authentication authorization model. These are all key things you want to think about in terms of your overall design. And of course, encrypting all sensitive data is pretty much a no-brainer there. Now, the good thing is you're not alone. You actually do have a large ecosystem of partners. I actually work on the partner team, so I spend a lot of time talking to folks like this. And some of you may be partners as well, which is great. Thank you. The idea here is that you don't have to build necessarily all these components yourself. There's actually quite a wide variety of partners both in the ISV space as well as even in the systems integration space that have a pretty solid understanding of how to build certain components in the overall platform. And we even have some partners that are focusing on SaaS as a consulting practice. We have partners that obviously focus on security components. There's a lot of different tools and capabilities that are made available to you. So before you jump in and build everything yourself, you probably want to do the due diligence to understand who can deliver certain key components of this platform for you, and then build an approach that takes into account how that speeds up your delivery relative to the cost of integrating those into your overall architecture. So the focus here, I mean, obviously we're talking about this because, and why we think SaaS makes sense on AWS is that what you need from a SaaS offering is ultimately flexibility, right? You need to be able to evolve quickly your customers. You heard Michelle Routh from Coca-Cola in the keynote. I think she made this case better than I ever could, which is customers are demanding a completely different software delivery model these days. They're looking for flexibility. They're looking for the ability for products to change quickly. They're looking for usage-based pricing. And in order to do that, you need a platform underneath that really allows you to do that. That's the core of how AWS thinks about what we're delivering, and the core of how it wires up and maps directly to what you're doing on top. So quickly responding to your customers is what you're going to want to do. And it'll look a lot like your innovation will look a lot like our innovation slides, in the sense that you're always rolling out new features, continuously delivering new capability, and a platform wired up to do that is really going to be critical for that piece. Another piece is that as your customers want more, they'll want things faster, better, cheaper. We like that thing as well. We like everything faster, better, cheaper as well. And so the innovation is a key piece. You want to innovate, and then getting a lot of these things for free. So things like the Lambda or container service, that's the kind of stuff you just pick up as you evolve, as the platform evolves underneath you, and then being able to stay up with those and evolve your platform to take advantage of them is critical. And of course, the ecosystem is a key piece to blend. So the one thing I would point out here is a little bit of a plug for me, I guess, and the partner program as a whole. So if you are doing SaaS today and you are not a partner yet, or if you are a partner but are not in the SaaS partner program, which would be highly likely since we launched it Tuesday, we do have a brand new partner program for SaaS. The idea here is to bring together a large number of people who are building SaaS offerings on top of AWS for collaboration. And then the ability to then build and grow on top of that, right? So we're going to provide, from our end, content like this and further content that will help you understand what we've seen in terms of best practices, but you'll get the ability to share information about what you're doing and what your customers are saying and what you need from the platform in a collaborative fashion. And then, of course, the idea as you grow, building out this platform and then growing with go-to-market activities associated with the AWS Partner Program. So definitely if you're a SaaS partner or a partner today or want to be a partner with SaaS, check it out. And then, of course, these are some of the things we're thinking about in terms of the initial launch. Office hours to Q&A, so folks like myself or others in the industry or in the AWS team focused on both business and technical issues, providing content and guidance. Reference architectures like these slides, as well as deeper content. Journey stories, customers sharing, like yourselves, sharing how you got there and what you learned along the way, so others don't have to make the same mistakes. You can compress that experience a little bit, although there's no complete compression algorithm for experience. And then partner solutions. So, as we talked in that ecosystem slide, there's several partners that are looking to deliver complete offerings around this, whether it be a platform or a service. In terms of integration services capabilities, getting a chance to hear from them what they might offer in a collaborative way. So here's some upcoming webinars we have scheduled to that end. So again, here's all the architecture best practices. I thank you for your feedback. I gave you actually an extra few minutes here at the end, so you have time, so you can't leave the room until you fill out the feedback form. I gave you that extra time for that reason. And if you have any questions, they're going to want to kick us all out of the room almost immediately after this, because they're going to break this thing down and turn it into a disco. So I'll probably go to the back and talk to folks in the back or out in the hallway if folks have questions as follow-up. So thank you very much for your time. Thank you for coming to reInvent.